Hello everyone. Today we're going to talk about arc length, section 6.5 in the notes. Okay? Just as a quick idea, let's talk about how we would figure out this. Well, if I have a curve, I can pretty much estimate it based on the x and the y and just turn it into a right triangle. Now that's pretty close. What would make it really close is if I took the derivative and had to go to 0. So by the Pythagorean theorem, I know that ds squared, the length of the curve, is equal to dx squared plus dy squared. Well, if I do a little bit of arithmetic, that tells me that ds is equal to the square root of dx squared plus dy squared. It's not negative because you can't have a negative length. Let's integrate both sides. Okay? And now I'm going to divide both of these by dx squared. And the reason I'm doing that is because this will now become 1. So that's the formula. That's what you need to remember right now. Remember this formula. This is your arc length formula. You'll be expected to know it on the AP test and on quizzes and tests in my class. So memorize it. It's the integral from a to b of the square root of 1 plus the derivative squared. Just one quick example because this is a pretty simple concept, and I'll let you use your calculator to actually integrate. But the formula says the integral from a to b, the square root of 1 plus dy over dx squared. In this case, it's going to be from 0 to 3, 1 plus, what is the derivative of y? Well, that one's really easy. It's negative 2x. Quantity squared dx. And it's just that simple. Plug it in your calculator, and you get about 9.747. We'll do a lot more examples in class, but this is the basic idea. Arc length is the integral of the square root of 1 plus the derivative squared. Again, you have to have that memorized for any AP test, quiz, or test in my class. If you have any questions, come talk to me. Thanks.